Bismillahirrahmanirrahim. We are going to start question number 5, which says find the multiplicative inverse of the following matrices if it exists by a joint method. Now, if it exists, how do we know that its inverse exists or not? We can know it because multiplicative inverse only exists for non-singular matrices. And which matrices are non-singular matrices? Those whose determinant is not equals to 0. If the determinant is not 0, then its inverse exists. And how to find the multiplicative inverse of a matrix? A inverse equals to adjoint of A divided by determinant of A, where this symbol A raised to the power minus 1 is called A inverse. Now we have to find multiplicative inverse of 4 parts, 2 of which are written over here. Now we are going to write the question over here first. 1, 2, 1, minus 1, 1, minus 2, 1, minus 1, and minus 1. Now this is your matrix and you have to find its inverse. So first of all, we are going to see if it's singular or non-singular. So determinant of A equals, now putting the entries over here, again the same entries. It is necessary that if you're finding the determinant of any matrix that you first write it in these straight lines and then you find it. Okay, it is equals to. Now first of all, we are going to choose any of the rows or any of the columns, but it's preferable that you use the first row. For the first row, you're first of all going to write the first number, then you are going to write its major matrix. What is major matrix? For major matrix, you first write the first number, and then considering this first number, you have to remove the row that contains that number and the column that contains that number, and you are left with 1, minus 2, minus 1, and minus 1, and you are going to write these 4 terms in the same sequence over here. You have to remember that you are going to write these 4 terms with the same sequence over here. You've written the first number and then the major matrix of that number over here in this way. Now you are going to write the second number but with a negative sign, minus into minus 1, and then you are going to write its major matrix over here. For this minus 1, you're going to circle this and you're going to remove this row that contains this minus 1 and the column that contains this minus 1, and you're left with these 4 entries, and you're going to write all these 4 entries over here in this determinant matrix. So you're going to write it over here in this way, and then the last term of the first row is 1, so we are going to write it over here, and then the determinant matrix over here, again this is the number, we are going to delete its row, its column, and we are left with these 4 terms which are going to be written over here. Now we are going to solve it just like we solved 2 by 2 order determinant, 1 in 2. Now we have to multiply the diagonals together, then put a negative sign, and then multiply the non-diagonals together, and it's over. Then minus into minus 1 gives us plus 1, into 2 into minus 1 gives us minus 2, minus sign as per the formula, and then 1 into minus 1 gives us minus 1. So this minus becomes plus, then plus 1 into diagonals multiplied gives minus 4, minus as it is, and then 1 into 1 gives us 1. It is equals to 1 into minus 3 plus 1 into minus 1 plus 1 into minus 5, and we get minus 3 minus 1 minus 5 equals minus 9. So this is your determinant, and as a determinant is not equals to 0, so it is non-singular. Now we are going to find the adjoint of this matrix. Why are we going to find the adjoint? Because it is equal to adjoint A divided by determinant of A. So to find adjoint, we are going to use a method. Now to find adjoint of a matrix, we first write it this way. For a 3 by 3 order matrix, we draw 3 determinant matrices inside. Sorry, I said it wrongly. We draw a 3 by 3 order matrix, and in the place of each entry, we draw a 2 by 2 order determinant. And then we have to place signs. The first one is positive, and positive is conventional, so we don't draw it, but then negative, then positive, then negative, then positive, then negative, then positive, and then negative. So there are 4 negative signs over here and 5 positives. Now we are going to write the 2 by 2 order determinant. For the first element, we are going to encircle this, remove its column, remove its row, and the 4 left over are going to be written over here this way. Now for the second element, you're going to encircle this element, remove its row, remove its column, and we are left with 2, 1, -1, and -1. So we are going to write it in the same order over here. For the third element, circle the third element, cut its row, cut its column, and we are left with these 4 elements, like I've written. Now for this element, you're going to encircle this, cut this column, cut this row, and you're left with these 4. So we are going to write it over here. And then the same for the rest of the 5 entries. In this way, we have written all of them. Now we are going to solve them all. Now open all these determinants. 1 into -1 gives us -1, then minus sign as it is, and then -1 into -2 gives us 2. Then minus sign as it is, and then we have -1 into 2 is -2, -1 into 1 is -1, so this becomes plus. Then we have this one, so oops. Okay, 2 into -2 we have -4, and then 1 into 1 we have 1 with a negative sign. Then we have minus into, then we have -1 into -1 gives us 1, negative sign, -2 into 1 gives us +2. Then we have 1 into -1 is -1, and then -1. Then negative sign, and 1 into -2 gives us -2 plus 1, and don't forget this transpose ever. Now we have to solve it. -3, then we have 1, then we have -5, then we have -3, -2, and 1, 3, 3, and 0 with transpose equals. Now we are going to take its transpose, transform its rows into columns. So we are going to have -3, 1, -5, then -3, -2, 1, -3, -2, 1, and 0, 3, 3. Now we are going to find inverse, and according to this formula, A inverse equals adjoint of A divided by determinant of A. So A inverse equals adjoint of A divided by determinant of A. Here we have -9 as the determinant and this matrix as the adjoint. So we are going to use both of these results in this. So 1 by determinant of A is -9, so -9 into adjoint of A is this matrix, so we are going to write it over here, equals to, now we are going to divide every entry by -9. So we have -3 by -9, -3 by -9, and 0 by divided by anything gives 0. Now we have 1 by -9, then -2 by -9, 3 by -9, again 3 by -9, 1 by -9, and we have -5 by -9, which gives -3 by -9 gives us 1 by 3, then 1 by 3, 0, -1 by 9, 2 by 9, 1 by 3 with a negative sign. Then we have 5 by 9, -1 by 9, and -1 by 3. And this is your answer. Now moving towards the second part. For the second part, now we are going to write the question over here first. 3, 2, 1, -4, 3, 0, and 2, 5, 1. And again, to find this determinant, you have to write the same entries over here again. 3, 2, 1, -4, 3, 0, and 2, 5, 1. Now, to find its determinant, we are going to write the first row over here, 3. There is a negative sign of already over here, and then a -4. And then we have 2 plus 2. And now we are going to write the major matrices. So for 3, we are going to encircle this entry, remove its column, remove its row, and the rest are going to be written over here. For this, okay, first of all, write them down. For -4, we are going to encircle this, cut this row, cut this column, and we are left with 2, 1, 5, 1. So we are going to write it over here, 2, 1, 5, 1. Then we have +2. So encircle it, cut its row, cut its column, and we are left with 2, 3, 1, and 0. So we are going to write it over here. To find its determinant, we are going to, for the solve it, 3 into diagonal entries gives us 3 and non-diagonal is already 0. So minus into -4 is +4, and then we have 2 into 1 gives us 2, minus non-diagonal entries give us 5, plus 2 into 0 gives us 0, and then 3 into 1 gives us -3, minus because of the already applied negative sign. Then we have 9 plus 4 into -3 plus 9. We have 6. Then we have 9 minus 12 minus 6 equals to 9 minus 18 equals to -9. Again, we have got the same determinant, which is not equals to 0, so it is non-singular. And because it is non-singular, so we can use it, we can find its multiplicative inverse. Now we have to find the adjoint of this matrix A. For adjoint, we are going to draw this whole structure as it is a 3 by 3 order matrix. So we are going to draw a 3 by 3 order adjoint, and for each entry we are going to draw 2 by 2 order determinant. And then we have to write negative signs on the on second term. So this is here comes the negative sign, here comes the negative sign, here and here. Positive, negative, positive, negative, positive, negative, this way, okay? And then we have to write the 2 by 2 order determinants. For the first entry, you're going to circle the first entry, remove its column, remove its row, and you're left with 3051. So you're going to write it over there. 3051. For the next one, you're again going to encircle it, remove the row, remove the column, and you're left with 2151. So you're going to write it over here, 2151. And the rest of them are done on the same way, 2310. Then we have -40, 2, 1, then 3, -4, 2, 1, 1, 3, 1, -4, and 0. For this we have -4, 3, 2, and 5. For this one we have 3, 2, 2, and 5. And for the last one we are having 3, 2, -4, and 3. And then whole transpose. So now adjoint of A equals, okay, right here transpose. Now we are going to find all these 2 by 2 order determinants, which are very easy. 3 into 1 gives us 3, -5 into 0, 0's term never count. And then -4 into 1 gives us -4, and then 0 into 2 gives us 0. And then we have -4 into 5, -20, -3 2s are 6. Then 2 into 1 is 2, -5 into 1 is 5 with a whole negative sign, then 3 -2, then we have 15 -4 with a negative sign as a whole, then we have 2 zeros are 0 and -3, then a negative sign with -4 into 1 with an already present negative sign, so we get 4. Then we have 3 3s are 9 minus plus 6, 8 equals. Now this matrix is given transpose. 3 remains as it is. Minus into -4 gives us 4. -20 -6 gives us -26. Then 2 -5 is -3 with a negative sign is 3. 3 -2 is 1. 15 -4 is 11 -11. Then we have -3, -4, and 9 plus 8 gives us 17. And now we are going to take its transpose. The rows are going to be converted into columns. So the first row is 3, 3, and minus 3. The second row is 4, 1, minus 4. And the third row is minus 26, minus 11, and 17. So we have taken the transpose. Now we have the adjoint, we have the determinant, so we can find inverse and we can put it in this formula. Now from here we know that this equation, we are going to write it over here. A inverse equals to adjoint of A divided by determinant of A. So this is the adjoint of A and this is the determinant of A, and we are going to write it over here. So first of all, we are going to divide the determinant. So we have minus 1 by 9, and then we are going to write this matrix over here. Now we are going to divide 9 by each and every term and also this negative sign. So we have, okay, so 3 by minus 3 by 9. Then we have again minus 3 by 9. Then we have minus 3 by minus 9. Here we have minus 4 by 9, minus 1 by 9, minus 4 by minus 9, minus 26 by minus 9, and minus 11 by minus 9, and then minus 17 by 9. It is equals to, now we are going to just simplify some of them, which can be, and the rest of them will remain as it is. So it becomes minus 1 by 3, minus 1 by 3, and then again minus 1 by 3, sorry. Then we have minus 4 by 9 over here, minus 1 by 9 as it is, and then 4 by 9 over here. Then we have 26 by 9, we have 11 by 9, and we have minus 17 by 9. And this is your answer for the second part.